everybody. Thank you so much for joining us for the chemistry of sauces, exploring food chemistry with Vernier. We are so excited to dive into a little bit of food chemistry fun with you all. So settle in, get settled. Um, while you are, grabbing that last minute glass of water, kicking up your feet, putting on cozy socks, whatever your pre-webinar ritual might be, go ahead and navigate to the bottom of your Zoom window. At the bottom of your Zoom window, you will see what looks like a little chat bubble. And if you click that, you'll be able to pull up the webinar chat. We are so excited and super down to answer all of your questions today, but we hope that when you submit your questions, you set that to section to everyone. Right now, I think the default might be 2 panelists or 2 hosts, something like that. We hope that you will send your question to everyone for 2 reasons. One, because sharing knowledge is part of what we're doing. And so by asking questions, you're showing to other people it's okay to be wondering things. We are all learning together. Other people might be wondering the same stuff. In addition to that, we're going to be answering your questions live, and we don't want to look like we're talking to ourselves. So please set your to section to everyone. To practice this skill, go ahead and navigate to that chat box and let me know, have the leaves started changing where you are? Here in Oregon, we are getting just a hint of golden leaves. I think I saw one tree that was totally changed, but besides that, I think fall has just started. And let's see what y'all are saying. So, a great fall weather in Kansas today. Awesome, Glenda. Feels like fall in Ohio. Hi, Diane. Good to see you. Terry's also in Kansas and also autumnal there. Leaves are still green in South Dakota. Yes, in Washington. Almost ready to change in North Carolina. Oh my gosh, Virginia, 80 degrees. Oh, and yep, in California, not changing yet. That makes sense.
Texas, yeah.
Yeah.
Yeah, checks out. Cooling off in Las Vegas. Good,
Well,
Mary.
at
Good to
least it's
hear.
cool, yeah.
Oh, and cooling off in Florida. Good. So we're all tiptoeing into fall, I guess.
I was riding my bike over leaves on the road yesterday when I was driving around. So they're falling off some of the
Yeah,
trees.
there's a couple bright red ones out in the park near my house, so some of them are changing for sure.
Yeah.
All right. Well, it looks like we're 2 minutes past the hour, and in an effort to get the most learning we can today in, let's skip to the next section. I just have some housekeeping items. You will get a recording of today's webinar. It usually takes us about 3 to 5 business days to get that edited, but as soon as it is edited, it's going to be live on both our website and our YouTube channel. They're both linked there. And you will get an email with a link to the recording once it is published. So keep an eye on your inbox. It's coming your way. In that email with the recording, you're also going to get a resources folder. In that resources folder, you can find today's presentation with clickable links, a certificate of attendance if you're using this webinar for professional development, as well as some other experiment files I think we have in there and other goodies. As soon as I'm done talking here, I'm going to mute myself and I'm going to dump the link to that folder in the chat. So keep an eye on that. And if you happen to misplace it, as I said, it's coming to your inbox. I also mentioned earlier, but circling back, we want to answer your questions during today's webinar. So, and it'll be a little interactive today as well. So keep that chat box open. Make sure that to section is set to everyone so that we can all have a conversation. If we happen to miss your question or if you think of it later, feel free to reach out to us. You can email one of these 2 fabulous presenters at chemistry@vernier.com. With that being said, I'm going to get you that link and I will pass the presentation off to Melissa.
Yes. Hi, everyone. And Dylan's not going too far because she's going to be one of our students today, just like all of the rest of you. We are going to have a little bit of audience participation as much as we can today, so stick around. I'm Melissa. I'm the director of chemistry here. And today's experiment is not officially written up yet. It's kind of hot off the presses. So there is an activity kind of written up in the folder that Dylan just shared, but we're really excited to share it with you today. And I'll let Nüs introduce himself.
Hi, I'm Nüs Hisim. I'm the second chemistry education technology specialist here at Vernier, and I taught chemistry and physics in Maryland for 34 years, and for the last 10 years, I've been helping Melissa with the chemistry questions and things that we do. So,
Yeah. And for those of you who are regulars at our webinars, Nüs does have on one of his food chemistry shirts. I was disappointed, though, that it was not the sauce periodic table shirt. So next time, we'll have to do
next
another
time.
sauce one. So today we are going to be talking about the chemistry of sauces. And in particular, it involves a lot of different elements of chemistry sauces do, but we're going to be talking about pH, conductivity, and reactivity in terms of CO2 production. So maybe some of you teach a food science class, and that's kind of why you dropped in here. But maybe you're also just looking for some more engaging topics to talk about with your science or chemistry students. Something a little bit more real world. The activity is NGSS aligned, and it is also tying into National Chemistry Week, which is coming up in a couple of weeks here. And the theme this year is the hidden life of spices. And if you have not gone to the ACS resources website to look at all their resources, if you want to get some, fun, engaging topics, activity ideas, things like that, definitely check out that website. But today's activity fits perfectly with that. It's also a really nice topic to talk about some green chemistry. We ask your students to bring in their own sauces from home. And that could be also a nice way to engage your students, have some cultural inclusivity. Their students can talk about their different cultures and the different sauces in them. So I think that's all a really nice tie-in to the National Chemistry Week theme. And maybe you even have a student bring in mole for Mole Day. I threw that one in there for you, Dylan, don't worry. All right, and so today like I said, we're gonna be looking at pH, conductivity, and we're going to be using the CO2 gas sensor to measure the production of CO2 gas when sauces interact with baking soda. So as you can see out here, I need lots and lots of little beakers. You could use little small Dixie cups. And really that's it. You need some baking soda, you need some graduated cylinders, and a lot of water to dilute out these sauces, particularly if you get a whole bunch of them. And like I said, have your students bring in their own samples, or you can provide your own if you want it to kind of have a little bit more structure to it. And we do need to dilute the samples. I am going to say before we get to, okay. So let's just go into the live demo. So we sell a couple different types of pH probes. And today I'm going to be taking data with our flat pH probe. And the flat pH probe is appropriately named because its end here, let me find a white background so you can see, is flat. There is not an exposed round bulb like you can see in the picture there on the slide. That is our standard pH probe. It has a teal electrode shaft, and then the bulb is exposed at the end. This one is flat. There's still a glass bulb in there. It's just flat and inside. It's also a double junction pH probe, so it is much better for measuring a bunch of gunky stuff. This is a very messy lab, and it's very messy for the sensors in particular. So I highly recommend the flat pH probe for it. If you use the standard pH probe, you just want to do a lot more cleaning and soaking. All right, so let's pull up graphical analysis. And I do have a temporary code here for you if you want to take that home with you. I am going to be using GA Pro today just because I want to be able to type in the names of the sauces. And GA Pro is great for that. It's also really good for bar graphs. You can still do this without GA Pro, but it'll just look a little different. So I type in my GA Pro code there and press submit. And now I'm going to connect. I'm going to connect my pH probe and my conductivity probe at the same time. So I push the little power buttons. They flash red, means they're broadcasting. And then I want to look at the serial number back here on the back. It ends in E4. So let me find the electrode amplifier that ends in E4 and press connect. And then I'm going to connect my conductivity probe the exact same way. It ends in D2 serial number. So I press connect. The other thing I want to point out that I found fairly useful in this activity is the fact that the conductivity probe has a temperature sensor in it. Not a lot of people know that. And I can engage that here by clicking this down arrow and saying temperature. So the reason I liked using temperature every once in a while, especially when you're mixing solutions or if you're going kind of quickly, it helped me keep track of if I was having any kind of weird artifacts. But and I also just wanted to point it out that it's there. So we're going to say done. And everything has defaulted to time-based data. I do not want time-based data. I want event-based data, which means I will tell it what the name of the sauce is. So I click in the little mode button, data collection settings, event-based. The name of my event is sauce. And I will say done. And I'm going to set this up so it has pretty data. pH on the top, conductivity on the bottom. And I also want to engage my meters to make these little tiny meters here a little bit bigger. And I do all that by clicking on this square of squares. I can change how many graphs I have. I can add a table and I can add meters. I can even add notes since I'm in GA Pro or a video. Okay, and now I am all ready to collect data. So, since this is very much a interactive, invite your students to bring their own sauces, how do sauces contribute to chemistry, why do we care type experiment, I have in front of me vinegar, Italian dressing, horseradish, sriracha, and soy sauce. I also have some others if we have time, but we're going to start with these 5. So Dylan, you were the student. What sauce did you bring today?
Today I brought the sriracha.
Ooh, that's very exciting. Do you think the sriracha sauce is going to be very acidic? Tell me a little bit about sriracha.
Yeah, so I know sriracha is it's spicy, so I think it is going to be acidic because I know when I eat something with it on it, my tongue kind of I feel it in my tongue. Maybe
Ooh.
that's acid. It's dissolving my tongue a little bit or something like that.
Oh, all right. That's very, very all good, interesting things to keep track of as we go down the line here. So for context, we're going to start off with vinegar. Dylan, do you think vinegar is an acid or a base?
I think that vinegar is an acid.
Okay. And how do you think its conductivity is going to register? Do you think it has a lot of ions in it?
I think vinegar is going to have a high conductivity.
Mm.
Yeah.
Okay, let's check it out. Let's see. So you thought it would be acidic. So what pH do you think that would be if it's acidic?
I think if it's acidic, I think it might be around well, I can see now.
Well, I know, but is it going to be high or low? Is
Oh,
an acid a high pH or a low pH?
low.
Okay, and then a conductivity of about 1,000 microsiemens per centimeter. So this is the reason I like to start with vinegar or with oil is to just give students context. They're not going to know right away, maybe, I mean, they probably know the pH scale, but conductivity scale is a little not as common or notable. So vinegar is a good place to start because it's got a low pH and a fairly low conductivity. And we're going to keep that and we're going to say vinegar. And then it's going to ask me if I want to convert to categorical data, and I do. And so the reason it has a low conductivity, at least in this situation here, is because it is straight store-bought vinegar. It's not a consumer-based product, and it's not a vinaigrette. So we're going to leave that there more for context. All right, the next one is our Italian dressing. So Dylan and the rest of the students joining us from around the country today, what do y'all think is going to happen when I measure the pH and the conductivity of Italian dressing?
Okay, well, I know Italian dressing is sometimes lemony, so I'm going to guess that Italian dressing is acidic, but not as acidic as vinegar. So maybe a pH of 3. Yep, Trina agrees. Thank you, Trina.
Oh, yeah.
And I think conductivity-wise, dressing I think of as slippery. So I'm wondering if it'll be more conductive because things can slip more easily.
Oh, I love that. So like it's slippery, it's oily, right? It has a lot of oil in it. We think of Italian dressing as being like oily and sliding over the salad leaves, and you have to it doesn't get quite on your salad very well and stuff like that. Awesome. All right, I love that. I love all those features. I love comparing it to lemon. You could even have your students obviously not in the classroom, but ahead of time taste it, smell it, do it in a safe way. But the fact that, I got a solid green light on my pH probe. I might have to restart it. But yeah, the fact that Dylan was like, oh, it's oily, so it must be more conductive. Which oil, typically we would think of as not being conductive, right? Because it's a string of hydrocarbons. But this is Italian salad dressing, so it's going to have a lot of salts and spices and flavors in it that are very conductive. And then certainly the oil and the salts and all that has to balance out and will give you, actually in this case, it's a fairly large conductivity. I am concerned about my pH probe though, so I'm going to keep this data point and reboot my pH probe so we can do a little bit of troubleshooting here in live time. Yep, my pH probe. So I got a solid green light. So to reset my pH probe, I'm just going to push and hold until it goes all the way off. Light turns off. Push it again. And now it should come back on my list. E4. Connect. And then we're going to jump right back in. Ooh. I probably should have stopped data collection before I did all that, huh? Okay, and now we're back up and running. Let's put the pH probe back in here. Okay, so the Italian dressing that you thought would be acidic because it's lemony, citrus, and yeah, it's pretty acidic, 2.82.
Nice.
All right, so we are going to append that data so we can continue taking it, and I'm going to do this again. All right. Next up, okay, excellent. So how did all the other students, what did they all think about the Italian dressing? Is everyone following along?
Yeah, we had some really fun conversations in the chat. First we were talking about oil, and then we were like, oh yeah, the salt content. Yeah, students, help me.
Yeah.
Lab group here. Come
I
on.
love that though. I love that, like when you think of oil, you thought, oh, it's like slippery, so it's going to have more conductivity. Like a student would totally think that, and you got to bring it down to the chemistry as to why it isn't. Um, so the next one we're doing is horseradish. So what do you think? What do you know about horseradish?
Man, it's hard because I know horseradish is so spicy, but I also think of it as and I don't know if this is true, a dairy-based
Oh,
sauce
is it because it's white? Maybe you
because it's
think?
white.
Okay. Oh, we also have resources. We can look at the bottle and see what's in it.
Okay.
There is horseradish roots, water, soybean oil, vinegar, corn syrup, eggs, sugar, salt, cornstarch, and then we're getting into preservatives. Oh, there's a little bit of lemon juice, xanthan gum to make it kind of sticky, and mustard seed. And then we're getting into the preservatives. So, yeah, did that give you any more hints?
Yes. So I heard lemon, I heard vinegar. So I'm gonna guess that it is pretty acidic.
Mm-hmm.
And conductivity wise, I don't know, lab group, what do we think? I'm thinking not conductive. Okay, Diane says salt will conduct. Oh, low. Okay. Okay, we're going to guess medium conductive.
Okay, medium. Yeah, we had kind of a low one and kind of a high one. It is, horseradish is really thick. It's really oily. So we'll see how much ions it has in it. So we put the pH probe in and the conductivity probe in. Wait for them to stabilize a little bit. Okay, so a little bit acidic, but not as acidic, so kind of keeps going up in acidity. And the conductivity is not very high. It's kind of right in between the first two. So pretty interesting. We're getting some dynamic here.
What I'm hearing is my lab group and I nailed it. Go team.
Yeah. Yeah, that's exactly right. There isn't a lot of interplay between, it's not just salt water, right? There's salt, there's oil, there's emulsifiers in it. So the thickness of the solution is really going to impact the conductivity and the pH. We're diluting these samples only by half, so we're still trying to keep the thickness as authentic as we can. But just like cooking, it's complicated. All right, so sriracha, this is the one that you brought in. And you said it was going to be acidic because you taste, it's spicy.
Bites the tongue.
Yeah, and now that you have some context with some of these other ones, what do you think? Do you think it's going to be real like as acidic as vinegar, somewhere in the middle?
I think it's going to be a little less acidic than vinegar, but more acidic than the Italian dressing.
Okay.
And I think conductivity wise, I'm going to guess it is not very conductive because what I'm learning is that salt plays an important part in conductivity. So I don't
Mm-hmm.
remember sriracha being super salty. So
Oh, okay. So you're associating the taste of salt then to how conductive it is.
great.
All right. Let's see. Let's see if she's right. Oh, yeah, a little less acidic and less conductive. Okay. All right. So it's actually getting a little bit more basic. So not quite as acidic as the rest, but it's a bit more conductive. Kind of interesting. Sriracha. Yeah, what does everyone think? Not as acidic as people thought. Yeah, despite how spicy it is, right? Some people it's like really spicy for. It's not as thick, just like in pouring the the sauces out and mixing them up, it's really not as acidic as you would think. Or, no, sorry, not as oily as you would think. All right, and the last one here is soy sauce. What does everyone think soy sauce is going to be?
Oh man. All right. Lab group, what are we thinking? I think soy sauce is going to be not acidic. So let's go 6 pH.
6. Okay, so almost, okay, all right, almost neutral.
No.
All right. Yeah,
And
no, that's
then
great. I mean, we haven't even tested anything that high yet, so might as well, right?
let's do
And then how conductive do you think it is?
I think it's gonna be very conductive, and it
Mm.
looks like my lab group agrees. So
Yeah, I saw a lot of conductivity flashing back there, high conductivity. So let's see. Let's test everyone's theory. Oh, yes. Yep, it's getting up there. And the pH is actually pretty close to 5. Wow, Dylan, look how much you learned from just these like 5 samples. I'm impressed.
hands-on learning, my friends.
Soy sauce. All right, and let's see. We're doing pretty good on time, so how about we pick one more? 1 or 2 more. I also, to give context, have oil that we can kind of round out and see. If you just have olive oil from the grocery store that you would mix with your vinegar to make your salad dressing, do you think it would be acidic? How do you think the acid and the conductivity would be?
Oh man, well in olive oil can't be acidic. A little acidic, Diane says. Ooh, okay. Let's go let's go like right in the middle. Let's go like neutral acidity. And then in terms of conductivity,
Mm-hmm.
I think not conductive.
Yeah. Yeah, and you learned that when you kind of originally thought it would be, oily would be,
Right.
and then now we've
Slippery.
kind of learned the opposite. So let's see what happens.
Ah, all right. Okay.
Also, a great opportunity if you're talking about properties of solutions. Oil, you're trying to dilute the oil the same way as you're trying to dilute all the other ones, and it doesn't mix very well. So a really good opportunity to talk about that. 4.8, so the closest to neutral, but still a little bit basic, excuse me, a little bit acidic. And oh my gosh, that conductivity, that's like less than tap water. I mean, that is really, really low. All right. Okay, and so that was plain old olive oil.
There you go. Elizabeth in the chat and I have a similar question, which is why would olive oil be a little bit acidic? Where's that coming from?
Excellent question. In this case, I would actually probably have to research that a little bit. If anyone has any ideas, throw them in the chat. In this case, I think it's having a little bit to do with the mix with water. So the water that's half water and half oil, so that's probably contributing to it a little bit. But yeah, the fatty acids and the carboxylic acid groups would all be contributing to that acid as well. So those are all great ideas, but yeah. Yeah.
Interesting. Yeah, it looks like people are suggesting, yeah, it has to do with how it's cooked or things like that. Fun. Another way that you can connect chemistry to cooking.
Absolutely, yeah. Okay, so we're gonna stop the data collection there. And we can go ahead and do a little bit of conversation around we kind of did all this discussion already, but which one had the lowest pH? So the lemon juice, the vinegar were the lowest pH. Italian dressing was also the lowest of kind of the ones we tested. Yeah, we talked all about that, so I'm not even going to go there. And then we talked about, oh, this is what I wanted to get to. So yeah, why, again, the students are like, well, why do I care? Now I know the pH of Italian dressing. How does that help me in my food science class, or understand why I would pickle vegetables with X solution or not? So the acids are responsible for changing the structure, right? Because they are going to help with the texture, help with leavening when you do baking, and they're also key in preservatives. So I intentionally, when Dylan and I were talking about this activity and coming up with this idea, we thought about fish sauce. And in fact, I have the jar over here. It is off the charts conductivity, like double what the soy sauce was. It was like pegging out the sensor, and it smelled so awful. And looking it up, it's used in a lot. It's fermented, and it's also used to help ferment other things. But it's a really, really good preservative because it has so much salt in it. So the ions, you can have something that's acidic and not ionic, or not acidic and really high ion content, and those do different things in the food science. And as we all talked about, the saltiness for the flavor, the sriracha that was more flavorful but not as salty, things like this. And then of course it contributes to preservation, because salt is really good at preserving stuff. All right, so next we are going to look at the chemical reactivity when mixed with baking soda to measure CO2 production. So before I do that, I want to save my data file. So I'm going to say File, and click on this Untitled, Save. And I am going to call this sauces experiment, and this is going to be pH and conductivity. And now I've saved it. I could also, if I wanted to take a picture of this graph and put it in a slide deck or a lab report, I could go to Export and individually save the pictures or copy them and paste them directly over into my Google Doc or Google presentation for my lab report. So I always like to show that. But we are now going to do a new experiment. And for this one, I'm going to show it to you in the web-based version of our application. So to get to the web-based, so if you have Chromebooks or if you just don't want to deal with IT, you can type in graphicalanalysis.app in your Chrome web browser, and it will bring up this view, looks exactly like the native app that we were just working with. And I can type in my GA Pro code down here and press submit. Oops. That's not the right code. Let me go back over here. New sir, Dylan, can you put that code in the chat again?
Yes, we'll find it real quick.
Thanks. I'm actually not even sure we need the pro version for this because we're doing time-based, but oh, thanks. Thanks, Catherine's on it. Oh, no, not that one. Let me see, did it not work?
Only 1P, it turns out.
Ah, there we go, 1P. Okay, perfect. And the reason I like to show off the web-based version is it does connect a little bit different. So you still push the power button. This is our CO2 gas sensor. Push the power button, flashes red. I still have to click wireless. And if I connected this via USB, I would have to collect via USB. So I click wireless, and then I look for K1. This is CO2 K1 at the end, and I have to click pair. And now I've connected to my CO2 gas, and I just say done. And now it looks, it's almost essentially exactly the same. So the only difference is really how you connect. For this, I have my kind of gas chamber reaction vessel that comes with the CO2 gas sensor, and it has 0.5 gram of baking soda in it. So for all the sauces you want to look at, you mix them with 0.5 gram of baking soda. And I've been doing 10 milliliters. So I have here 10 milliliters of horseradish or 10 milliliters of Italian dressing. And they're still the just diluted by half with water. Which one should we test? I think we're only going to have time for one. Which one do people want to test, the horseradish or the Italian dressing? Remember, the horseradish was, I have the data right here. The horseradish was pretty low conductivity. The Italian dressing was pretty high conductivity. They had similar acidities.
I think I'm seeing horseradish win.
All right, horseradish. Okay, so I am going to change a few settings here in the time-based. I like to take data a little faster than this. So I'm going to take data at 2 samples per second. And I'm not going to sit here for 10 minutes, so I'm going to turn it down, the duration to 300. And say done. And okay, so horseradish it is. So there's a little bit of a technique when you are adding, when you're getting data from the CO2 gas sensor. And I'm just pouring my 10 milliliters directly in here. I do want to give them a little bit of time to react. So I kind of swirl it a little bit. I put the CO2 sensor in the flask or Nalgene bottle. I press collect, and then I want to keep swirling to let everything, you could also like have it on a stir station. All these things you can do like with a stir station and things like that. But we did it kind of more ad hoc today. And I kind of want to swirl it around for a while until I see it going up. And I like to do it for about the first 30 or 40 seconds. And then I kind of, then I don't have to swirl it as much. But every once in a while I give it a swirl. All right, so we would think that, and like I said, we're only gonna have time to do one. Vinegar and baking soda, right, is the kind of the classic activity where you get lots of CO2 gas and it's really strong and measurable. And I'll pull up the sample data here in a little bit, and that would be the case here as well. Your vinegar is going to be your strongest producer of CO2 if you kind of follow the same methodology. But surprisingly, yeah, horseradish is really reactive and going up pretty quick, pretty fast. If you do this with soy sauce, what would you think? Would it be really reactive or not so reactive? Remember, soy sauce had really high conductivity, so it had a really high salt ion concentration. Not as reactive. All right. Why do we think that horseradish sauce is more reactive than the soy sauce? What do you think, Dylan?
Oh man, I think it's because, let's see, there's more acids in horseradish.
Yeah, so yeah, you could bring it to acid. So let's look at while that finishes collecting. Let me show you the reaction that we're monitoring right now. So here's the equation. We have acid and baking soda, right, is gonna produce more CO2 gas. So the theory would be the more acidic the solution, the more CO2 gas would be produced. So that's why vinegar produced the most. However, we found, right, that, and horseradish was more acidic than soy sauce, but not by a whole lot. But we know that the horseradish has a lot more oils in it, and that also contributes to the reaction if it's hard for the acid to come in contact with the baking soda, because the solution is so oily or it's not homogeneous because we had to mix it with water. All those things would contribute. So that might get a little bit more interesting when you start looking at, yes, soy sauce is going to be the least productive, but there's sriracha is going to be in the middle, and Italian dressing is going to be in the middle, and horseradish was just really high. And so you have to consider kind of all those things and how well the baking soda reacts. Yeah, let's see the final. I mean, that's really high, 25,000 ppms. And it just keeps on going. So then you can, again, talk with your students about, why do I care? Why does it matter how reactive the sauce is, or what factors influence the reactivity? If it's thicker, if it's more sugary, so the sriracha, which we think of as not having that much salt, but has a lot of sugar in it, or marinara sauce was kind of interesting because it was kind of right in the middle. That slows the mixing, and so all this kind of swirling and stuff like that, you have to do that consistently with all your samples, because if I just left the horseradish there without swirling, it would be lower, because the gases wouldn't be able to escape as well. We already talked about oils, and the more preservatives that are in it, so similarly the soy sauce, although salt is used as a preservative agent, but if it has like other kind of artificial preservatives in it, that will soak up all those hydrogen ions, so that'll slow the reaction. And yeah, so lots of really interesting things to talk about. That's why I was like, Dylan, you have to be the student in today's activity. This will be the most boring presentation if there's no one to kind of interact with around this. And I knew there would be lots of questions. So that is the activity. Again, it's kind of written up in that Google Doc. Hopefully we will get a full write-up for it soon. But if you're looking for some other food, spice-related experiments for National Chemistry Week coming up, we have a brand new Why Did My Tea Turn Purple experiment, which uses the pH probe and the spectrometer. We also have analyzing sports drink with the spectrometer, so definitely check those out. We also have an entire food chemistry book to look at and play around with. So those are all excellent green chemistry experiments. If you are a green chem aficionado, we are doing a call for papers jointly with Beyond Benign, which is a great nonprofit that has this green chemistry teaching and learning community that's basically like teachers sharing experiments. So if you're really trying to find some new experiments for your class, sign up for the GCTLC, and it's totally free. But also submit for a call for papers if you have some activities you're really wanting to share with people. And then if you have any questions, comments, concerns, please email us at chemistry@vernier.com. We also have chat on our website. And we are doing a giveaway today. So while Dylan is getting that person drawn, definitely put any last questions you have in the chat, and give us all your feedback, questions, comments, concerns.
Yes, and I dropped a survey in the chat there. It has no bearing on the giveaway. I've put everyone's names into a random name generator, and the winner of a Go Direct Conductivity Probe is Sharon C. So congratulations, Sharon. I'm going to email you a form that you can fill out so that I can get some shipping information. So keep an eye out for an email from someone with an email at vernier.com. That'll be me, and I'm just getting some info. So congrats, Sharon.
Yay. The other thing I do want to emphasize, I don't see any new questions coming in. The last thing I want to emphasize, this was a very messy lab. There was lots of messy solutions. You do not want to just have your students leave the pH probe and the conductivity probe in the solution for a long period of time, or leave it in there at the end of class. You definitely want to make sure you rinse these off really well. You can even use a little bit of dilute detergent and a very soft brush, especially with the conductivity probe, because things will get stuck in those, in the plastic there. Or if you're using the standard pH probe, definitely get all that stuff out there. But you are welcome to use the pH probe and conductivity probe with all these types of materials. Just make sure you clean them. And yeah, if you have any other questions, put them in the chat. But I'm glad everyone loved it. And hopefully you'll let us know how this activity goes with your students. Yes, thank you, Nüs. You should definitely remove the CO2 probe from the moist environment. Also, if I was going to take another set of data, I would kind of shake it out to make sure it could be ready sooner. And you have to store the pH probes in solution. Yes, you do. So I have been, because we've been going back and forth between solutions, I've just had a little container of water. But when I'm done with this and I clean it off, get all the oils off, anything that would clog the membrane, I put it back in its storage solution that it shipped with. It's a pH 4 buffer with some potassium chloride. And then I can put it on the shelf just like that. Oh, do you have any tricks for keeping the storage solution from molding? So the best trick is that potassium chloride you can make it a little bit more saturated. That'll help. There is some mold inhibitor that comes with the Flynn kit. But the truth of it is, it's just going to happen. And depending on your environment, if you're in a more humid area, you're going to have to replace it. Typically twice a year, I usually say. If you're like in, the desert, maybe once a year. But the mold inhibitor tries, but I haven't. Yeah, exactly, Nüs. Still have to change it. Yeah, so how should we replace it? Twice a year. Anytime you see mold, replace it. If you see mold in there, again, you can use a brush and some mild detergent. Yeah, mold does not hurt the probe. You just need to get rid of it. Just get rid of the mold. You don't want it to be, because the mold will eventually then there won't be any solution left, and there won't be any more, nutrients for the pH probe. So you do need to replace it. You don't want the mold to be there. You don't want mold to get up in the pH probe. But just dump out the mold, rinse the pH probe, rinse the storage bottle, and replace it. Yeah, thanks everyone, and have a great rest of your day.
Thanks, everyone. Bye now.